Hello friends, today again we'll be solving a question related to signal and system. So the question is as follows. Uh, what is the Fourier transform of a signal which is x of t equal to e power minus 3 mod of t signum of t? Okay, so we have to find the Fourier transform and the options are given. So let us first draw these signals, okay, because it's a combination of two signals. So e power minus 3t 3 minus 3 mod of t, it is drawn like this. Okay, so this is for both t less than 0 and for t more than 0. You can notice one thing here, that it's a even function. Okay, even function means for t minus t negative or t positive, the signal is the same. Okay, or the signal value is the same. So this is a even signal. Now the other signal is signum of t, which is equal to 1 when t is more than 0, and it is equal to minus 1 when t is less than 1, and it is 0 at t equal to 0. So it's a odd function. Okay, because when you put minus t, so the magnitude also changes to negative. So it's a odd function. Now when these two are combined together, the resultant function is a real and an odd function. Okay, so the magnitude lies in the first and the third quadrant. So for t less than 0 or for t more than 0, you can see that the graph is such that the entire function becomes an odd function. So we can write that it is a real plus an odd function. Okay, so there is a property, or there is a direct relation between real and odd function in the Fourier transform. Okay, so when you do a Fourier transform of real plus an odd function, you get imaginary and odd function. Okay, so this is a very important property that you get in Fourier transform, that whenever a real and odd function is there and its Fourier transform will be imaginary and odd. Okay, so using these two you can eliminate some of the options. Like the first option, if you see, you it is a even function. Okay, so a cannot be the answer, so directly we can neglect a. Okay, a is not going to be the answer. Now b, you can see it's a odd function, so it can be an answer. C also. Okay, C also can be one possibility, but D is again a even function, so this is not going to be the answer. So options B or option C are among the possible answers. So we have to choose between these two. So that can be done by actually integrating and finding the Fourier transform. Okay, so how we can proceed is, we can write all this thing mathematically as x of t is equal to e power minus 3t for t more than 0. Why? Because for t more than 0, sine of t is 1, so signum of t is 1, so it is going to contribute 1 to the magnitude. And you can see that for t more than 0, this t is positive, so we can simply write it as e power minus 3t. Okay, now for t less than 0, signum of t will be negative, so and it is minus 1, so that minus is reflected here. Again, it is e power minus 3 of minus t. Why? Because for t less than 0, t is going to be negative, so to ensure that it is positive, we have to use a minus sign again. So it is 3 of e power, so the we have e power minus e power minus 3t. Okay, for t less than 0. So now we have the function for the entire range for t minus infinity to infinity. So what we can do is we can directly jump to the integration now. Okay, so the integration is as follows. Now again I am reminding you that real and odd function. So this is a very important property. Real and odd function will have a Fourier transform of imaginary and odd. Okay, so let us proceed using keeping this in mind. So again I have written the xt as shown, and now we know that x of omega is minus infinity to infinity x of t e power minus j omega t into dt. So this is going to be our x of t. Okay, so now what we can do is, because our x of t is different for t less than 0 and t more than 0, we can break this integration into two integrals. One is from minus infinity to 0, where it is e minus e 3t, so it is minus e power 3t, and for t more than 0, it is e power minus 3t. So we have broken down into two integrals. Okay, this is the first integral and this is the second integral. Okay, you can write it as first and this is as the second integral. So what we do now is we can write it in this form. Okay, e power 3 minus j omega into t. So this is just what I have done is I have combined both the exponential and after that I have got this. Okay, so for both the exponentials I have done the same thing. Now what we can do is we can use this property. Okay, not a property, this is the integration. Okay, integration e power a t dt is e power a t over a. Okay, so now what is a here? Okay, this is the a. Okay, this is a for the first one and this is the a for the second one. So 3 minus j omega is the a for the first one, and 3 plus minus 3 plus j omega minus of 3 plus j omega is the a for the second one. Okay, so once we use this, okay, now what we get is this is our integral. Okay, e power 3 minus j omega t over 3 minus j omega, this is the integral we get, and these are the limits 0 to minus infinity to 0. And for the second case we get e power minus 3 plus j omega t over minus, okay, this is because this is a now. Okay, this entire thing was a, I told you, like this was the entire thing was a, so there is another minus sign here. Now both of them have a minus sign, so what we do is we take out that minus sign here. Okay, and we have taken out this minus sign here. Okay, and then we have simply put the limits here, e power 0 minus e power minus infinity plus e power minus infinity minus e power 0. So you know that e power minus infinity will go to 0. Okay, so these two will be 0. Okay, this is equal to 0 and this is also equal to 0, and finally we are left with this uh, this in the end, and this is 1 over 3 minus j omega and minus 1 over 3 plus j omega. And again if you calculate it, you get you can take the LCM. Okay, so LCM is taken here and we get minus 2 plus j omega over 3 minus j omega 3 plus j omega, this is the LCM we have taken. Now again if you do this is this as a plus b and a minus b, so this is a minus b and a plus b, so a square minus b square, when you use that you get 9 plus omega square. Okay, and above you get is j 2 omega. Okay, so b is the correct answer. Now you can check one thing. See, you can easily conclude that it is imaginary. Okay, it is purely imaginary. Okay, there's no real term to that, only imaginary term is present because of this j. Okay, and it is odd because of this omega. Okay, when you put minus omega, the magnitude will turn minus. Okay, so you have just concluded that real plus even. Okay, if I write real as r plus even real plus odd as o, then its Fourier transform will be imaginary plus odd. Okay, so using this simpler property also you can directly eliminate some of the options, and many a times the options will be such that you don't have to do this entire integral. Just looking at the properties you can conclude what is going to be the Fourier transform. Like for real even, okay, if I write this, the Fourier transform is real plus even. Okay, for imaginary odd, like I say, it is real and odd. Okay, so it's how it's going to be. You have to memorize some of these properties and it becomes very easy for you to solve these questions. Okay, so thanks for watching this video.